Here we go. Here's the next video on R.4. So R.4, and we are looking at factoring polynomials. So factoring polynomials deals with the distribution property. So we're going to take out the common terms, the greatest common factor. So we look at all our terms and see what's similar in all of them, and say, hey, there's a y in all these. There's no x in all of them, but there is a y. So let's go ahead and take out a y. But we take out not the greatest amount, would be the smallest amount of y's. The greatest that they have in common, but the smallest amount of y's when you're looking at the variables. So we can factor out, pull out a 3y, and then we look at our numbers. What can we pull out here? We can pull out a 3, right? So we pull out a 3y cubed, or undistribute, however you want to say it. And so basically that is division. So I'm dividing each of these terms by 3y cubed. Y cubed over y cubed is 1. So, and then 6 over 3 is 2. So I get left with 2x squared. Here, 9 divided by 3 is 3. I'm not taking out any x's, but I am taking out 3 y's. So that means out of 4, there's still 1 y left. And this one, 18 divided by 3 is 6. And there's 5 y's. I'm taking out 3, so there's 2 y's left, so y squared. So that's unfactoring. Now I have, instead of 3 separate terms, now I have kind of 2 terms, one monomial and one trinomial. And so now I have multiplication in between here. So if I distribute back in, I'll get to my original. So that's factoring. We're looking for common factors to factor out of our polynomials. All right, so here's a bigger, more complicated example. Those were just with x's and y's on the last one. But here we have our common factor is actually m plus 1, this whole factor m plus 1. That's the factor that's what we're going to take out here. So in each term we have an m plus 1 in each of them. So in the greatest amount, here's 3 of them, here's 2 of them, and here's 1 of them. So I'm going to factor out a whole m plus 1. And then I look at my numbers. Well, they all have 7, so I can take out a 7. So I'm going to go take out a 7 first. So that means on this one there's a 2 left. On this one there's a negative, 4? And on this one there's a negative 1. I probably should leave some space there. And on the last one there's a negative 1. So when I factor out, I'm actually dividing. So I'm taking out an m plus 1. So m plus 1 over m plus 1, that's going to be gone. Here there's 2 of them. I'm going to take out 1. So there's still 1 left. Okay. And then here, there's 3 of them. I'm going to take out 1, so there's 2 of them left. Okay, and then you can go ahead and FOIL this m squared out. So we get m squared plus 2m plus 1. And this one we can distribute that negative 4. And then we have a minus 1 over here. And we still have our factored out term. 7 times the quantity m plus 1. Now we can combine like terms, so we get minus 4m and 2m, minus 2m. We get 1, minus 1, 0. We get minus 4. So we get m squared. So then we have simplified, might look something like this. Oops, what did I forget? I forgot this 2 right here. So after I FOIL, I could distribute that. So that's actually a 2 there. This would turn to a 4, and this would turn to a 2. So this is actually completely gone. So that's actually completely gone. There's a 2 here. 2m squared. 4's gone, then we have 2 minus 1. And so we get, what, negative 3. So minus 3. All right, there we go. So it might be simplified to look something like that. Okay, another form of factoring is factor by grouping. So this is when you have 4 terms or more, and they share common terms. So the 2 sets share common terms. So we want to maybe rearrange these 4 in some kind of order that when we take out, we're going to take out from 2 of them. So there's one set of 2 and another set of 2. So I'm going to take out something that's similar here. So I'm going to take out an m. So I'm left with a p squared plus 7. And when I factor out of this second one, what I want to factor out is anything that's common, but in a way I still want to leave. What I want to leave is the same exact grouping here. Okay, so this two group will be the same. So in order to do that, I would need to factor out a 3, right? And there's still a plus sign in between there. There's still a plus. It's not multiplication. So now I'm going to factor again. So now I have this term and this term. And now I can factor out the p squared plus 7. So I factor that out, p squared plus 7. And then what's left is the m plus 3, right? Because factoring out is dividing, so when I divide by that, that's gone, and that's gone, and I'm left with an m plus 3. And then I check, see, can I factor this? No, I can't factor that, so that's it. Okay, here's another group. I have 4 of them, so I look for factor by grouping. So this one, this second 2, I can't really factor anything else, anything out of that, except for maybe a negative. So maybe a -1, I get left with a positive and a positive. So this one, when I factor out the front, I want to factor out, so I get left with a 2x plus 1. So that one I can factor out an x squared, so I can take out an x squared. Okay, and I also need a 1 here, so it needs to be a 2x squared. So when I factor that, I get a 2x and a plus 1. And so this negative, I can bring down a plus sign if I want, but this -1, that negative takes care of the kind of the plus sign there. But you can leave it in here if you want. So now, what can I factor out of this group and this group? I can factor out a 2x plus 1. So what is left when I factor that out? An x squared minus 1. Now, if you recall from last year, this is a difference of a squared here, and 1 I could rewrite as something squared, 1 squared. So it's a difference of squared, so that factors into conjugates. So 1 plus x, or x plus 1, and an x minus 1. We practiced with this with foiling the other day. So there are factors into that. So factors, why we want factors a lot of times is because when we factor and it's set equal to 0, then I know, because factors get multiplication, and I know when I'm multiplying numbers, if my answer is 0, that means one of those factors has to equal 0, and that's a big thing that comes in now and in calculus and in other things. Except for, of course, man, I factored out a 2x squared. So you probably saw that. So there should be a 2 there. So that means there should be a 2 there. So that means I'm not going to have conjugates. Jeez. I'm messing everybody up. That's what I get for making these videos after a long day. All right, there you go. So it factors into that. And I can't, there's no difference of 2 squares, because 2, I can't rewrite 2 as something squared. So they're fixed. Okay, factoring trinomials, you guys remember this? If you were in my class before, CAB, you could do the reverse box method, a reverse FOIL kind of thing. You might have to guess and check, that might work too, but here's your A, here's your B, that's a plus sign, and here's your C, so I take A times C, so 1 times 6 is 6, and then my B is 5, and then I ask myself what times what is 6, so that's 2 and 3, that is also 1 and 6, and then whatever the sign is, it's a positive here, so it can be either, these both can be negative or they both can be positive. I look at the sign here, it's positive, so that means they're both going to need to be positive. So if I add these, what plus what? So 2 plus 3 is 5. So my factors are x plus 2 and x plus 3. And so if I FOIL that out, I can see I get to that. So when it's not equal to 1, I can still do CAB, so I get -30. So because my CA is negative, that means I want to subtract. 1 needs to be negative, so that means I need to subtract to get to my B, and my B is -7. So I'm going to subtract to get to that B, and then just the bigger number is going to be negative because this one's negative. So we get 30. So what times what is 30? So what times what is 30, but subtracts to 7. So that's 5 and 6, but that just subtracts to 1. I get 15 and 2, so 15 and 2 is not going to work. What else? 3 and 10. Oh, so 10 minus 3 is 7. And because my B is negative, the bigger sign is negative. The bigger number is negative. So those are my factors, -10 and 3. So x minus 10 and x plus 3, but because I multiplied C times A, So because I multiplied my c by my a, I have to divide by that a, so I have to divide my answers by my a. So then I just reduce these fractions. 1/2, so x plus 1/2. And when you're setting equal to 0, you can leave as 1/2. Reduce this fraction to 5/3. Okay, but because this is not at psi equal to 0, I'm going to take this denominator here and move it in front of the x. Take this denominator and move it in front of the x. So if you haven't been in my class, this is probably foreign to you. So I apologize, but you can guess and check. And you can practice these. You can look up videos. You can do reverse box method kind of thing too as well. But there's my answer for that one. All right, here's another one. So if you want to, you should try these by yourself before we practice in class, just so you get more and more practice with these. The more you practice, the better you get. Okay, so 2 times 18, that's a positive. So my factors are either both going to be positive or both going to be negative. So that's 36. And so that means because that's positive, that means I'm going to add up to my b, and my b is negative 13. And because that's negative 13, that tells me that both my signs are going to be negative. So something that adds up to 13 and multiplies 36. So we get 12 and 3. So that's 15. We get 18 and 2. So that doesn't work either. We can try 9 and 4. 9 and 4, yep. That adds up to 13. But because my b is negative, that means both of these need to be negative. So my factor is x minus 9 and x minus 4. But because I multiplied by my a, I now need to divide by my a. This doesn't reduce, right? So I can put that in front. And this does reduce. And then what I can always do is just check my work, especially to get this first one. So 2x times x is a 2x squared. So always check that first one at least. But those are my answers there. All right, here we're talking about the difference of squares. So whenever we have a difference, so subtraction, and we can rewrite the first term as something squared and the second term as something squared, then we can factor it in a plus b, a minus b conjugates. So I can rewrite 4 as 2 squared, and I can rewrite m as m squared, and I can rewrite 9 as 3 squared. So really, my first term is 2 and m are being squared. So that's my a. So this will factor to 2m, and then my second term is a 3 being squared, so plus 3 and a minus 3. What I like to do on these when it's bigger ones is really just say, okay, what's being squared? Well, the a plus 2b is being squared, so that's my first term. And I look what's being squared here, so I might have to rewrite this. Sometimes I just put a line when it's like this, and I say what times itself is 4, 2, and 2, so 2 is being squared. What times gets me c squared? C and c, so c is being squared. So 2c. I can just do 1 minus and 1 plus. And you can do some. You could do brackets there. There might be another set of parentheses right there. Or you can take those down. I mean, those can come down. But that's how you do it. Okay, difference of cubes. So if I have a difference, it's a minus b, and then the next ones are all plus. And then you just, a is being squared, and then a times b, whatever your first thing being cubed is and second thing being cubed is, and then b squared at the end. So m is being cubed, and then 64 is not being cubed. N is, but how can I rewrite 64 as something cubed? So that would be 4 cubed. So 4 and n are being cubed. That's my second thing. My first thing is m. So this is going to factor to m minus my second thing being cubed, which is a 4 and an n, so 4n. And then I write my a squared, so that's the first thing that's being cubed squared, so m squared. Then a times b, so m times 4n is a 4mn. And the last thing is that's being cubed, I go ahead and square that. So 4 is being cubed and n is being cubed, so I'm going to take 4n and go ahead and square it. And so that is a 16n squared. Okay, so that's the difference of cubes. All right, sum of cubes we can do, as well as just, if it's a sum, the first one's is a plus, and then over here it's a minus, where difference of cubes, those switch orders. So you got to figure out what your first thing being cubed is x. Second thing, I need to rewrite 125, so that is 5 cubed. So x is my a and 5 is my b. So it's a plus b, so it's x plus 5. And then a squared would be x squared. A times b, and it's just a negative. So that's x times 5 is 5x. And then b squared, so it would be 5 squared, which is 25. Okay, good thing to remember here is your perfect square. So that's 3 times 3 is 9. So 9 is a perfect square, 16 is a perfect square, 25, 36, and so on. Perfect cubes are, oh, 1 squared is also 1, so 1's a perfect square. 1 cubed, so that means 1 is a perfect cube. 8's a perfect cube, 27 and 64, and so on. So remember those. And then you can recognize a difference. So that's subtraction, difference, and addition. So you have a difference of 2 squares and a difference of 2 cubes, but you only have one sum of cubes. You don't have a sum of squares.